So, since your exams are near, all of you guys would be giving exams in a few weeks. So now what we are going to do now? In every class, for the first few minutes, we are going to take up some questions from the previous chapters. Okay? We're going to take some questions from the previous chapters, and then we're going to continue with the current chapter in the batch. Okay? So today I am going to ask questions from you guys from the chapter microorganism, friends and foe. And this is the chapter that is common for all of you. All of you would be having questions from this chapter in the exam, right? Right, Vaiga, Ibrahim, and Aisha. Okay. So you guys answer this to me that who was the person to have discovered the vaccines for the first time? Who discovered vaccines for first time?
Edward Jenner.
Okay. What about others?
Sir, I don't have microorganisms friend and foe.
You don't have. Okay.
No, sir.
Ibrahim, what about you?
I have.
You have no. Okay. Okay. So anyways, like Edward Jenner, as you answer, he was the first person to have discovered vaccine, a first successful vaccine, we would say. Okay, now, and he discovered the vaccine for which problem? Was it the smallpox or the cowpox? It was
Cowpox.
no. It was actually smallpox.
Yeah, sorry, smallpox, sir.
Okay, no. Also, he has been called as father of immunology. Okay, no. He has been called as father of immunology. Anyways, okay. Answer one more question to me. Do tell me, like, there's a parasite. There's a protozoan that causes malaria. What is the name of that protozoan? Anyone
So
can
what?
answer. What is the name of the protozoa that causes malaria, because of which malaria is caused?
Plasmodium.
Plasmodium. Very good. Okay. In preparation of curd, which bacteria helps? Which bacteria multiplies in the milk and converts it into curd?
Lactobacillus.
Lactobacillus.
Very good. Okay. Okay. To tell me, what is antibiotics? What are antibiotics?
Like the medicines which kills or like stops the growth of the disease that is causing microorganisms.
Good. Good. Basically, antibiotics are the microorganisms, or kind of they are dead or weaker versions of microorganisms. Right now, they will be manufactured by growing specific microorganisms, and they are used to create a cure a variety of different diseases. Generally, bacteria and fungi are used to prepare antibiotics. Okay. Okay. Tell me that. Give one commercial use of the yeast. Give one commercial use of yeast. Yeast, which is a fungi, what is its commercial use?
It produces bread.
Not produces, used in the preparation of bread. Okay.
Yes, sir.
Okay, good. And do tell me, what is pasteurization? And Ibrahim, you will be explaining the method of pasteurization, how pasteurization is done. And Vaiga, you tell me, what are the different methods of food preservation? What are the different ways in which food can be preserved? It can be prevented from getting spoiled by bacteria or fungi and other microbes.
Okay, sir.
Just come on, you guys start answering. We don't have much time.
Freezing, canning.
Freezing. Okay, this was supposed to be answered by Vaiga. You have to answer what is pasteurization. Okay, Aisha. See, if you are facing difficulty, you can ask me. I will be happy to help in this. Okay, no need to hesitate in this. Basically, pasteurization is the
In pasteurization, we heat the milk to high temperature to kill most of the harmful bacteria.
Mm-hmm. The exact temperature to which milk is heated is 70 degrees Celsius. For about 25 to 30 seconds, milk will be heated to this temperature, and then it will be suddenly cooled, suddenly chilled, right now. So in two manner, we are killing the bacteria. First by heating, then by cooling. So most of the bacteria will be killed here. That is the thing. Okay. Yes, what are the different ways of food preservation? Yes, Vaika.
Okay, so like heating or smoking it,
Okay.
and then boiling,
Okay.
like salt and sugar,
Good.
and then we can like preserve it like in storage and packing.
Good. Aisha was saying about deep freezing or canning. So canning is also one of the ways of preserving, right now.
Yes, sir.
We can use some chemical preservatives also, like sodium benzoate can be used, citric acid can be used. Like citric acid is present in lemon now. Citric
Yes,
acid is
sir.
present in lemon, and lemon is used in pickles.
Yes, sir.
Sun drying is one of the most common method. Okay. Okay. Do tell me, who discovered the disease anthrax? Huh? Who discovered the microorganism that causes anthrax disease? Yes, Aisha, you had
Said
given the test on this also. Yes, Vaika.
Robert.
Mm-hmm. Hi, Robert Koch. Right
Oh,
now,
yes.
Robert Koch. He was the person to have discovered the microorganism that causes the anthrax disease. Okay, now. Okay. Anyways. Okay. Answer some more questions. Ibrahim, you tell me which is the mosquito that carries the plasmodium? Hmm. Which mosquito is responsible for spreading malaria? A very simple question. Yes. Anyone else?
Female Anopheles.
Female Anopheles. Very good. Okay. Um, Aisha, name five friendly use of name five uses of microorganisms. Name five uses. Okay. And Ibrahim, you will be telling about the harmful microorganisms. In what manner microorganisms are harmful for us? Yes, quickly. Yes, Aisha. The first you can answer like it will be helping us in several manner, like making of the curd, the most common example. And Vaiga, you can also answer.
Okay, sir.
And many more are there. So many antibiotics are prepared using the bacteria and fungi like
Yes, sir.
penicillin, streptomycin, erythromycin.
Yes, sir. Like some of the microorganisms like bacteria, like the two common examples of the bacteria is like lactobacillus and rhizobium bacteria.
Okay. Rhizobium bacteria, where is it present? Present in the root nodules of leguminous plant.
Oh, yes, sir.
We
I
have
forgot the name of the plant.
we have a pea plant. Pea plant is an example of leguminous plant, right?
Yes, sir.
Okay, so basically what it does, the rhizobium bacteria, it fixes atmospheric nitrogen gas and enriches the fertility of the soil by releasing nitrogen compounds in the soil. Okay,
Yes, sir.
that's the thing. Also, bacteria, so many microbes will be cleaning the environment by decomposing the organic matter present in the dead plants and the animals. They recycle the nutrients in the preparation of the bread. Yeast is used, right? We have commercial use of microorganism like for manufacture of
Yes, sir.
alcohol, beer, wine, and vinegar on large scale. Microorganisms are used.
Medicines also.
Medicines also, no? So many
Yes, sir.
bacteria, fungi are used in preparation of antibiotics. That is the thing. Also, we know about the fermentation. Who discovered the fermentation for the first time? Who discovered this method? of fermentation? Ibrahim, you haven't been answering. You have been so quiet. Yes.
So Pasteur.
Louis Pasteur. Louis Pasteur, very good. In the year 1857, he discovered this method for the first time. Basically, sugar grains were converted into alcohol by the action of yeast. By the action of yeast, sugar grains were converted into alcohol in the method of fermentation. Okay. Then what is vaccination? What is vaccine and what is vaccination? Yes. Anyone? Aisha?
So like a vaccine contains like the weak or like killed forms of microorganisms.
Mm-hmm. Which are harmless, no? Which are harmless.
Yes, sir. Yes,
And
sir.
when they are introduced into a healthy body, the body fights and kills those microbes by producing antibodies, right?
Yes, sir.
And also they will remember how to fight those microbes if they enter our body again. And the antibodies that are prepared now, that they will be remaining in the blood. Okay, now they will
Yes,
remain
sir.
through the whole life of that person or that animal. Okay.
Yes, sir.
And
And
vaccination is
and the
Can-
vaccination is the process of giving a vaccine by injection, which provides the protection.
very good. Okay, can you guys tell me some of the common diseases for which vaccine is given?
Coronavirus.
Very good. Most common example we have.
That's so easy.
That's easy. You have other examples like you have a smallpox, hepatitis is there, cholera, tuberculosis. So these are some examples. Anyways, let's continue with this chapter. We were doing the chapter chemical effects of electric currents. Okay, like in every class for the 5 to 10, for the first 5 to 10 minutes, will be taking up questions from the previous chapters. Okay, Brahim, your network connection is not stable. Okay, not a big issue. No worries. Okay, no? But make sure, if I am not audible to you, then that is a big issue. Okay, no? Anyways. So talking about the chapter so far, what we have learned, we learned about conductors and insulators in this, like what are conductors and insulators. So we know that basically conductors are materials that will allow the electrons to pass through it easily, or basically it will allow the electricity to pass through it easily. While insulators, they are the materials that will not allow the charges to pass through it. Hence, they will not be conducting electricity. We learned the basic difference why certain materials are conductors, why certain materials are insulators. In the case of conductors, we learned that the electrons are free to move. They can freely move from one place to another. So thereby electricity will be conducted. But in the case of the insulators, like you have example of dry wood, diamond, oil, glass, rubber, they do not allow the electrons to freely move through it. Hence, electric current is not, they do not conduct the electricity. That is the thing. Today, we are going to continue from this topic. Okay, now, does the liquid conducts electricity? Just as some of the solids will be conducting electricity, in the same way, some of the liquids can also conduct electricity. By the way, can you guys give some example of solids that will conduct electricity? Give some examples of solids.
Solid.
Yeah. Solid.
Gold and copper.
Aluminum.
Aluminium, iron, right? Copper. So almost all the metals will be conducting electricity, whether it be like copper, iron, gold, aluminum, silver. They are good conductors of electricity because they will allow the electrons to move freely through them. But the materials like these are also solid, like rubber, glass, diamond, dry wood. They are also solid object, but they are not conductor because they will not allow the electricity to pass, or will not allow the electrons to flow through it easily. That is one thing. Talking about the case of the liquids, there are some liquids, like for example, the substances that are in the liquid state. There are some substances that are in liquid state. Like for example, you have a acid. You have a solution of acid, or base or salt. So they will be a good conductor of electricity. Getting it what I'm trying to say? You have an acid water. Let's say you have you take water from the battery. The battery contains sulfuric acid in it, right? Sulfuric acid is found in the car batteries. So this sulfuric acid present in the car battery will be a good conductor of electricity. Getting my point? Because it contains acid in it. Or you have a basic solution. Let's say you have taken sodium chloride, sodium hydroxide, I mean to say, sodium hydroxide, and you mix it with water. So that water will be a good conductor of electricity. Or if you have added salt in the water, all those will be conducting the electricity through it. Got my point? So there are some liquids, for example, solution of an acid, base, or salt conducts electricity. They conduct electricity. Okay, you guys can write down the important points also here. Okay, note down the important points also. So you have some examples, like the examples can be taken as solution of sulfuric acid, or solution of hydrochloric acid, that is HCl, solution of HCl. Where in the body this HCl is secreted? In which part of the body HCl is secreted?
In the stomach.
In the stomach. Okay, no? In fact, not just in the case of we humans, more in the stomach of most of the animals, this hydrochloric acid is secreted. Okay, no? We have some other acids also, right? Basically, any acids in water will be conducting the electricity. You can take example of some weak acids like vinegar. Vinegar contains acidic acid, no? Right? Vinegar has acidic acid in it. Acetic acid. Vinegar, that is silica, basically, which we have at kitchen, used in the food. So that also contains acid. Lemon juice. What acid is present in the lemon juice? Who will tell me? Which acid is present in the lemon juice?
Citric acid.
Citric acid.
Pronounced as citric acid. Okay. Citric acid is present. Okay, so all these will be conductors of electricity. So far we had taken example of acids. Now let us take example of bases also. So we have solution of baking soda. Baking soda, that is sodium bicarbonate. So we have baking soda. You have a sodium hydroxide.
So can you read the first sentence?
Solution of baking soda, this one. Okay, some liquids in brackets solution of an acid, base, or salt conducts electricity.
Okay, sir.
So you have sodium hydroxide, you have potassium hydroxide. What is all this I'm writing? All these are the different examples of bases. Okay, now potassium hydroxide. So all these will be containing the electricity. Okay, so these were the bases. Then we have example of some salt, like you have common salt, that is sodium chloride. You have copper sulfate, or any other salt will be conducting electricity in the solution when it is mixed with water. So then we have some examples of like solution of sodium chloride or copper sulfate. So all these will be the good conductors of electricity. But then you have some examples of liquid that are not good conductor of electricity. Like for example, sugar solution, it's not a good conductor. Some oil like kerosene, it's not a good conductor. Sugar solution is a bad conductor. Some vegetable oils, they are bad conductors of electricity. Getting the point now. So not all of them are good conductors of electricity. We have some examples which are bad conductors of electricity. So it should be clear so far. All right. Now take the case of some take some other cases like distilled water. The distilled water that we drink. So distilled water, it's again a bad conductor of electricity. It will not allow the electricity to flow through it. Hence, you see that this bulb is not glowing here. The bulb is not glowing here. While this water, which had some impurity in it, it made the bulb glow. So, what was the reason behind that? And why all these liquids like the sulfuric acid, solution of sulfuric acid, hydrochloric acid, vinegar, lemon juice, baking soda, sodium hydroxide, potassium hydroxide, sodium chloride, and copper sulfate? Why all these are conducting electricity? Because the thing is that when electricity passes through these solutions, so these solutions breaks up into charged particles called as ions. Vaika and Ibrahim and Aisha, you guys understood about the ions? It was discussed in the previous class.
Yes, sir.
Ibrahim, say yes in the chat box if you understood that. Aisha, I think you were absent in the previous class.
Yes, sir.
Uh, So basically, ions are not charged particles like you can understand it in this manner. Okay, what we know that anything that we see around us, any matter that we see around us, they are made out of atoms. Atoms are the tiniest particle of a substance that you can think of. So atoms are the most fundamental particle that we have. So say that this is an atom. This is the structure of an atom. Now the center circle that you see, this is called as the nucleus. What are the particles present in the nucleus of an atom? Vaiga and Ibrahim, you guys tell me.
So electron, proton,
In the nucleus I'm asking. In the center of an atom.
proton,
Proton plus neutron.
neutron.
While this is called as the orbit of the atom. Okay, now Aisha, you particularly pay attention. So this here, another particle floats around the nucleus. It basically rotates around the nucleus, does a revolution around the nucleus. That is called as electron. And it is negatively charged. Okay, it is negatively charged. While inside here, you had this one. See that this is proton. That is P. And this is neutron. That is N over here. So proton is positively charged. Electron is negatively charged, while neutron has zero charge on it. Now, if an atom has equal number of proton and electron, pay attention here, Aisha. If an atom has equal number of proton and electron, by the way, before that, one proton has one positive charge. So two proton will be having two positive charge like that. Okay, now Ibrahim, Vaiga. So Aisha, one electron will be having one negative charge. Two electrons will be having two negative charge like this. So ideally, in an atom, if it is in a nuclear state, the number of proton will be equal to number of electron. It is, let's say 5 proton are there. So there is 5 electron in it. The charges are balanced here now. Like you are 5 positive charge, 5 negative charge here. Yes or no, Aisha?
Yes, sir.
Also, you guys turn your cameras on. For those of you who can turn their cameras on in the class, turn it on. So at this moment, the atom is said to be in a neutral state. It is in a neutral state. While I'm explaining this, others write down all these things also. Write down the important things here. Okay, now give the topic: can liquids conduct electricity?
Okay, sir.
So 5 proton and 5 electrons are present. So the atom is in a neutral state. The numbers are balanced, so it's in a neutral state. But somehow, if the number of electrons were to increase, let's say it increases from 5 to 6. There are now 6 charges on it. 6 electrons are on it now. So the number of proton is 5 only, but the number of electron has increased to 6 now. So how many extra electron is there? Yes, Aisha? Earlier there were 5 proton and 5 electron. Now there is 6 electron. Somehow there is 6 electron. So there is one extra electron here, right?
Yes, sir.
So one extra electron will make it negatively charged. Because when you calculate the overall charge on this, 5 plus 5 positive charge plus 6 negative charge. So 5 minus 6, you're getting minus 1. So there's a negative charge on the atom. Getting it what I'm trying to say. the overall net charge on the atom is one extra, since one extra electron is there, so it is said to be negatively charged. Got this thing now? So when an atom gains an electron, it becomes negatively charged. But if it were to lose the electron, now let's say that it loses an electron, now the electron is only 4. So which is more? Now here, is the electron more or is the proton more? Aisha, is the electron more or is the proton more?
Proton.
Proton, no? So the overall charge will be, there's one extra proton here, right? So they by atom will be said to be positive now. Now the atom is positive. Earlier the atom was negative. So when an atom will be losing or gaining the electrons, so it becomes charged. Either it can become positively charged or become negatively charged. And as we know, like an atom is basically the smallest particle. So when they become positively charged or negatively charged, then we call them as ions. Then we call them as ions. Got this basic idea what is ion?
Yes, sir.
That is the thing. So the water which has some impurities in it now, like you have a muddy water. So when electricity will be passed into that solution of water containing mud or some other impurities, so that solution will be breaking up into ions. The solution will break up into the positive and negative ions. Hope that is clear.
Yes, sir.
Okay, now? And make sure that you go through it from your book also and go through the recording of the previous class. Otherwise, there's a possibility that you might forget it over time if you don't get to revise it. Okay, now Vaiga, tell me, what are the two types of ions? What are the two types of ions? Namely, we have cations and anions now. Cations and anions, right? Which one of them is positively charged? Guys, am I not audible in the class? Hello?
No, sir, you are audible.
So cations are positively charged. Okay, Vaika and Aisha and Ibrahim. While negatively charged ions, they are called as anions. Anions, okay? So that is the thing. Any confusion so far? Yes? If not,
Yes, sir.
let's move to the next
Okay.
topic then. Good. So we were talking about the case of the water here. So the question is it a conductor or is it an insulator? The case here is that the water that we get from different sources like tap water or hand pumps or well or ponds, it is not pure but a solution. It is not pure but a solution. What do we mean by this? Like solution, it's not pure. Basically, say that if I were to have a mineral water, I am having a mineral water. So let's say just I have taken a distilled water. So distilled water only contains water in it. There are only molecules of water in it. Only water molecules are present in it. Particles of water are only present in this. But if I were to have tap water, so tap water will contain some impurities in it. Like this will contain magnesium in it, or salts of magnesium will be present in magnesium salt, or calcium salts will be present in it. Because they were seen like in certain parts, in certain areas, the water will be heavier, and over time the bucket will develop a coating on it. On the surface of the bucket, a coating will develop on the bucket. Getting my point? What I'm trying to say? Have you guys seen such thing like a over time now the inner surface of the bucket will develop a layer on it, a thick layer will develop on it, that whitish layer that develops on it. It is because of presence of magnesium or calcium in it now. That makes the water hard. Anyways, getting back to the topic, here it not only contains the water molecules, but it contains other impurities in it also. Getting the thing what I'm trying to say? It contains magnesium salts and it contains calcium salts in it, apart from water molecule. So it has multiple components in it. There are multiple things in it. These things that are present in the water, although they are present in a minute amount, they are called as solute. And these solutes are dissolved in the water. So the water is the solvent. So there are two components in this. There are two things. One is solid, one is solvent. So then it is said to be impure. So a solution basically impure thing will be made out of solute and solvent, meaning that two components will be present. Like for example, you have lemon juice, or let's say you make a you dissolve some sugar, lemon in water, sugar and lemon in water. You get a solution now. You have a glass of water. In this, you have added some sugar in it, some lemon juice in it. Lemon juice and sugar were added in a small quantity. They were added in the small quantity. So the one that is added in the small quantity, that is called as solute. And the medium in which it is added, which is always in major quantity, that is called as solvent. So it is added in the water, which is in a higher amount. So the water here is the solvent. Got my point? What I'm trying to say? What is the solute and solvent? When these two are mixed, as a result of mixing of solute plus solvent, you get a solution out of this. Is this thing clear to all of you? What I'm trying to say?
Yes.
But can we say distilled water or solution? Can we say distilled water or solution? Yes, Vaiga, Aisha. Can we say this? A solution. Is there any solute in this?
No.
No. So this is not a solution. This is not a solution. And also this is pure. Since
Yes, sir.
nothing is mixed in it, it's not a solution, so it is pure. But this tap water, these things are added in it, although in very small quantity, and they are solute. So there is solute and there is solvent. Both of them becomes a solution, and solution is always an impure substance. Like air is also a homogeneous, heterogeneous mixture of different gases. Although it's a homogeneous, but in the troposphere it is heterogeneous. Getting back to this, what the conclusion of the discussion here is that the water that we get from the tap water or from the hand pump or from the well, they are not pure, because pure thing only contains solvent. There isn't any solute in it. It's made out of only one thing. But a solution contains multiple things in it. Solute could be there, so many solids like magnesium salts, calcium salts are present in the tap water, and solvent is that is what is there. So thereby it's a solution and it is impure. So the small number of the mineral salts are naturally present in it, like this magnesium and calcium salts. So thus this water is conductor of electricity. Why it is conductor of electricity? Again, the basic question is that because when electricity will flow through that water, the water will break into ions, as you guys can see here. Say we had taken the example of tap water in this. So as the electricity passed into this now, upon passing of the electricity, the tap water will break into positive and negative ions. Getting my point? Whatever minerals, whatever components are present in tap water, whatever impurity is present, it will break into the positive and negative ions. That's why this is a conductor, while distilled water or some other things is not a conductor. Is that clear to all of you? Please let me know.
Yes, sir.
If there is any confusion, please let me know. If there is any confusion in this, please let me know. All right. Moving on to the next topic, that there we have some substances here. When it went under the test, like here.
Esther,
Yes.
can I just use the restroom?
Okay. So we have some of the materials like distilled water. It's a poor conductor, as we have discussed. Tap water, it will be a good conductor. Why tap water will be a good conductor? Because it contains impurities in it, and upon passing of the electricity, those impurities in it will break into ions. Lemon juice, again a good conductor. Vinegar, a poor conductor. Cooking oil is a good conductor. Milk is also a good conductor. Honey, it's a poor conductor. While soda compounds, this one over here, soda compound, it's a good conductor. Mercury, good. While fuels are poor conductors of electricity. These are some of the general materials, and we got to know which one of them is a good, which one is a bad conductor of electricity. That's the thing. Okay. So far we were learning about the case of the liquids. So whether liquid will conduct or not. We know that in the solids, electricity is carried by the electrons in the case of solids, but in liquids, electricity is carried by the ions, namely the ions, positively and negatively charged ions. Like as you guys would be aware, if you guys can look into, as you can see, like there's a conductor. So you say that you have a copper wire. So in the copper wire, how is electricity conducted? It is because of flow of electron. Electron flows from here to here and from here to here. So it is because of the flow of electrons, electricity is conducted in a solid material. But in the case of liquid materials, how is electricity conducted? Electricity will be conducted due to flow of ions and not because of the flow of electrons particularly. Getting the point I'm trying to make here? Let me write it
Yes,
down.
sir.
So the first important point is say that in case of liquids, electricity flows, electricity is carried by ions, namely positive, that is cation, and the negatively ionized, that is anions. Hope it should be clear. Okay. Say for example, let us take this example. Have a look at this image. Okay, for example, have a look at this setup. Here we have taken this liquid, and this liquid contains copper sulfate. What does it contain? It contains copper sulfate in it. Let me see if we have another diagram here. This one here. Okay, look over here. Here we have a battery, a switch. There are two rods. We have been learning about it later on. These are the two rods. Okay, now, and there is this liquid, and the liquid is copper sulfate here. So in a solid like copper metal, this copper metal, electricity is carried by the electrons inside a copper metal. Inside this, electricity is carried by the electrons here now. This is a solid material. What moments ago I told you that in a solid, electricity is conducted via it is carried by the electrons, right, Aisha, Ibrahim, and Vaika? But in this liquid now, the electricity will be carried by the ions. Namely, you can see this copper positive ions and sulfate negative ions. Copper ions, these are the copper ions and these are the sulfate ions. So when we would talk about the liquid, so in that case, the electricity is carried by the ions, namely here in this case, copper and sulfate ions. What is all this setup? We'll be learning in detail when we'll be talking about electrolysis. But tell me, is this thing clear?
No, sir. Can you please repeat again?
Sure. See, while we were talking about the conduction of electricity inside this copper is a solid or liquid? Obviously a solid substance, right?
Yes, sir.
Moments ago here we did discuss this thing, that in a solid material, like in a copper wire, electricity is carried by the flow of electrons, right? Right, Ibrahim? Electricity in a given solid material is due to, it is carried by the flow of electron. Then we learned in the case of the liquids, what I say, that in case of liquid, electricity is carried by the ions and not by the flow of electrons, namely cations and anions, positive and negative ions. So by the example of this here, what we see that we have, like, these are the copper wires. And let me just explain the circuit here. These are the copper wires. There's a battery here, and these are two metals. Both of them, in fact, are copper. What is happening in this? We'll be learning about that later on. Okay, now it's like purification of copper using electroplating. Once you will be learning about electrolysis, then it will be more clear. But this part of the discussion about the electron and cations and ions, it will be clear. Now, when electricity is passed on, it goes into the copper rod. No, when electricity goes onto the copper rod being a solid conductor. So here the electricity will be flowing due to the electrons now, as moments ago I have told you, right? Electricity is flowing because of that. Getting my point or not? Also here,
Yes, sir.
the circuit is completed. Okay, it's not empty, like the circuit is not open. It's completed because flow of electricity takes place between these two rods. Electricity is flowing here. So electricity from one rod goes to the next rod, not via the electrons, but it is carried by the ions here. So in the case of liquids, electricity is carried due to the flow of ions. That is what I'm trying to say. But in the case of solid, electricity is carried due to flow of electrons, but in liquid, it is due to flow of ions. By now, I think it should be clear.
Yes, sir.
Aisha, did you understood this? Ibrahim, Weiger?
Yes,
Good.
Yes, sir.
So that was the thing. So this was the first important point. Okay. Also, when electricity is passed through a solid object like this electrical wire, like this copper wire, do you get to see any chemical change here? Any chemical change? Like the smell of the wire changes, the color of the wire changes, it releases bubbles or anything like that? No? Obviously, no. Yes or no? Please let me know. But when
Yes, sir.
when electric current passes through a liquid, then a chemical change takes place. So when electric current passes through a liquid, then chemical changes will be taking place. Chemical changes take place. There are numerous ways in which those chemical changes can take place. Okay, like for example, when electricity is passed through a given solution of water, let's say, like have a look at this video over here, both of all of you. I suppose I should be having this here. In fact, we did saw this video in the previous class. So we had a sample of water, and that is not pure water. To make it impure, we added some acid. Took the acid from a battery. So this guy took some acid from the battery. He added the acid into the water. Now see what happens in this. What is catching fire? All this right now not relevant to the discussion. We'll be learning about why it caught fire later on. As of now, just see that while electricity will be passing into that water now, bubbles will be forming. Just pay attention to where the bubbles will be forming. We took the notice the sulfuric acid was present in the battery. Now from on these test tubes, the bubbles were formed. The bubbles were formed. Did you guys observe that over here? Look over here, from here again. Observe this. Observe this now. See, there were some bubbles. Can you guys notice the bubbles? very tiny bubbles were formed.
Yes, sir.
So basically what happened here now, like what we know in a chemical change, new substances with different properties formed. So at those two test tubes now, at one of them, the hydrogen gas was formed. Now, and the another one, oxygen gas was released. So here, isn't it a chemical change? Bubbles are formed, and a compound is splitted. A substance goes through goes through the reaction, and it is split into hydrogen and oxygen. And both hydrogen and oxygen have different properties. They are completely new substances as compared to water. So isn't this a case of chemical change, guys? Tell me.
Yes, sir.
Aisha, you're not getting it. And Viger,
Yes, I'm getting it.
getting it now? Good. So that is one of the another thing to be noted down here. Okay. Okay. Also, the liquids which conduct electricity, we'll simply call them as conducting liquids or conducting solutions, right? That is the thing. Also, the chemical changes which takes place in a conducting liquid on passing electric current through it, they are called as chemical effects of electric current, upon which the chapter is based upon right now. The chemical changes which take place in conducting liquid on passing electric current. Let me just write down this thing. It is really important. So the thing is that the chemical changes that take place in conducting liquids on passing electric current through them are called chemical effects of electric current. Effects of electric current. Hope it should be clear. Okay. Now, furthermore, all these liquids that you have seen so far, the examples of liquids which were conducting electricity, they are known by a term called as electrolyte. Should I change the slide? Are you guys taking noting it down? Yes, Vaika, are you noting it down, Ibrahim?
Yes, sir. Yes, sir.
Okay. The chemical changes that take place in conducting liquids on passing electric current through them are called chemical effects of electric current. That is the thing. So, Aisha, in order to make a distilled water conduct the electricity, what should I do? Distilled water, it's a bad conductor of electricity, but in order to make it a good conductor, what should I do? Like distilled water, it's a non-conducting liquid. It does not conduct electricity. But to make it a conducting liquid, what should be done? Viger, Ibrahim, Aisha,
We should
continue.
add acid.
You should add acid or salt or either base in it. Very good. Okay, now.
Yes, sir.
Now, what about the sugar solution or kerosene oil or the vegetable oil or the honey? They are non-conducting liquids. Okay, now.
Non-conductors.
Good. Okay, should I change the slide now?
Sir.
Viger, done?
Yes, sir.
Okay. So in this, you can see some non-conducting liquids. One more example was the sugar solution. So that's also a poor conductor of electricity. Poor conductor. Is the kerosene written here? No. Write down the example of kerosene also. Kerosene is also a poor conductor of electricity. Vegetable oil is also a poor conductor of electricity. Right. That is the thing. So the important thing of the discussion was around the ions. Right now, getting it now. So
Yes,
while
sir.
you'd be you would be reasoning about why any liquid will be conducting or why it will not be conducting electricity. So you must mention the reason that ions are present in impure liquids. Ions are present in the impure liquids, but in the pure liquid, ions are not present. So it has got to do with the ion, I mean to say. Okay. Then we have one more thing to be discussed, that why LED bulbs are more suitable for testing the electrical conductivity of the liquids. Okay, who will tell me the full form of LED? Anyone? It's light emitting
Light
So what?
emitting
diode. I asked the full form actually. Light emitting diode. Okay, now. So the light emitting diode is used in place of a bulb for detecting whether a current is flowing through the given liquid or not. Right now, here like a lamp has been used, but let's say in place of this lamp, we should be using a LED bulb. Okay. So why it is preferred? Because let's say if this liquid which we call as electrolyte, it's a conducting liquid and we call this as electrolyte. Let's say that if it was a weak electrolyte, it is a weak electrolyte, meaning that it can conduct electricity but not that good. Let's say you had added just few salt in it, few amount of salt in it, so it will be a weak electrolyte. To make it a strong electrolyte, you will have to add a good amount of salt in it. So let's say you have added just a sprinkle, you have just sprinkled few salt in it, so it's a weak electrolyte. So it will allow the current to pass through it, but not that much. Right now, not that much. And as we know that this bulb, like this is an incandescent lamp, it requires good amount of electricity in order to conduct. It requires good amount of electricity in order to glow. Right. Also, this bulb is based upon the heating of effect of electric current, not about the not upon another effect. Like this incandescent bulb, it glows due to heating effect of electric current, right? Heating effect of electric current. That is what it is based upon. Like this has a wire called as tungsten wire in it, right? Tungsten wire is there, and when this tungsten wire is heated, then it glows and gives out light. But if the magnitude of the current, if the strength of the current that is passing here is very weak, so will it ever glow? If
No,
there
sir.
is right now, so if the electrolyte is weak, so the electric current flowing in it will be weak, so thereby this will not be glowing because it will not get that much of heat. Also, this is based upon the heating of electric current. So in that case, we will not be able to detect the nature of the electrolyte properly. So thereby we take help of, we use the light emitting diode basically. Also, to important thing to be noted down, there are two ends of the LED bulb. Okay, now there are two ends. The longer, by the way, these are called as LED. LED. Okay, now these are called as LED. The longer LED is always connected to the positive terminal of the battery. It is connected to the positive terminal of the battery and the shorter one to the negative terminal of the battery. So that's it for today. From the next class, we'll be learning about some other things, okay? Like how we can use a compass as a tester, okay? Then we'll be learning about electrolysis.